You're going to like lesson 2-4. You are. More about linear equations. I mean, we have lots of different forms that you learn starting in pre-algebra and then in linear algebra and then in exponential algebra about lines. And hopefully with bringing your memory back, I'll just give you a little bit to help you remember. We should be able to use this without any trouble. So what we're going to do is we're going to write an equation of a line given its slope and a point on the line. So if we know a point and somebody says, hey, here's the slope, what should we do? And this is the fabulous formula that fits the bill. Point slope form. They said they were going to give us a point, and they were going to give us the slope. What better formula could we possibly have? There it is. M is the slope, and x sub 1, y sub 1 is, big shocker, the point. Well, sometimes that brings the question, well, what about the other x and y then? What are they? Well, they're all the points on the line that make this true. That's what those are. All those x's and y's in there. All the points that make it true. So what are we going to have to do? We're going to have to find that point that's on this line, and we're going to put it in those two spots, x and y. Then we're going to figure out what the slope is, if we have to. Sometimes they just get it to us. And then we're going to simplify it. That's our job. So this formula does a lot for us. Now here's the bad news. They don't give you this formula on these units. I don't know why, because I think it's really silly. On the formula sheet, they have y equals mx plus b. You don't usually need y equals mx plus b because you already know y equals mx plus b. They don't give you this formula, but you need to know it. You absolutely do. And for years, my Algebra 1 and Algebra 2 students would ask me to find a song or something to help memorize that. There just is no nursery rhyme that fits that. It's just kind of weird. So I guess we just kind of remember it as, it's that kind of weird formula with the y minus y sub 1 equals m times the plot of the x minus x sub 1. We're already to an example right now. Write an equation for the line passing through the point with the slope. Well, that's point slope form. That's what it's for. So y minus y sub 1 equals m times the quantity x minus x sub 1. And our job is to put the point in for x and y and put the slope in for m and see what happens. Well, that will be x sub 1, y sub 1. So I'm going to put a 3 in here, y minus 3. I'm going to put a negative 2/3 in for m, and then x minus a negative 1. I'm going to tell you flat out that most people skip x minus a negative 1. Because what's x minus a negative 1? Most people will do that in their head. Bless you. Now, if the problem says, write an equation for the line passing through the point negative 1, 3 with a slope of negative 2/3 in point slope form, we're done. That would be as far as we go. But most of the time, we try to make sure that we can put this in y equals mx plus b, because usually it's like, okay, now graph it, do something like that. So what we do is we keep doing the math, and we say, let's distribute that negative 2/3. So y minus 3 equals negative 2/3 of x minus 2/3. And then we're going to add 3 to both sides. But then I realize, okay, I'll either use my calculator and do negative 2/3 plus 3, math number 1, or I can change 3 into 9/3. So I'm going to add 9/3 to both sides. And that will give me y equals negative 2/3 x plus 7/3. So again, if you don't like looking at the fractions, don't grab your graphic calculator. Let the graphic calculator do it. Punch in parentheses negative 2 divided by 3 parentheses plus 3 equals math number 1. And it will give you 7/3. It will. So don't let the fractions here pull you a job. Okay? You can do it with a graphing calculator. So now I'm going to have you talk me through this one. What is an equation for the line through this point with this slope? Well, let's see. That looks like a perfect fit for point slope formula. So think about it for a second. What is the left side of this equation going to look like if we put that stuff in like we're supposed to? Y plus 1, good. Y minus the negative 1 is y plus 1. How about on the other side? Minus 7. Now how do we get this in the slope intercept? And we're going to be careful because we've got negatives. So what will that be if we do that? Plus 21. Everybody see that? Plus, minus, which is it? 50-50? Negative and a negative. Positive. Almost done. Good. Y equals negative 3x plus 1. So that formula is fabulous. Thank goodness for that formula. And we'd be doing a lot of work to get these equations. So that's one big part of our objective for today. Look at this one. They took something away from us. You mean book writers? What is an equation for a line passing through the ordered pair 5, 1 and 7, 9? Leave equation in point slope form. Well, we have points. I mean, that's what we need. So we have to use the point slope formula. Do we know how to find slope? Well, then let's do it. We can find slope. We can make this work. So it'll be 9 minus 1 over 7 minus 5. 8 halves. Oh, me like me. What's that going to be? Yeah, no fraction. Got ourselves a really nice slope. You want to use 5, 1 or 7, 9? Okay, let's use 5, 1. It will be y minus 1 equals 4 times the quantity x minus 5. Okay, but this has got me thinking. What if somebody used the other one? Y minus 9 equals 4 times the quantity x minus 7. What was that like? How is it going to turn out? They look totally different. Here's why. You don't write down these steps because this said leave it in point slope form. If we put this into y equals mx plus b, it's going to look like this. And if we put this one in slope intercept form, it's going to look like that. How can that be? We started off with two totally different sets of numbers. How could they possibly give us the same equation? Think about it for a second. What were these points for? Isn't this an equation for a line? If we don't want the other one to be a different equation for a line, which it's not, we better get the same thing. So this is the reason that most of the time the book will have us put these into slope-intercept form, because they only want to put one answer in the back of the book. Because how many points are on a line, everybody? An infinite amount. They don't want to put all those answers in the back. So what they do is they say, you know what? We'll just tell them, go all the way and put it in slope-intercept form, so that way we can put one answer in the back of the book and everybody can check their answer. So that's the reason we usually take that all the way to the end, so we can check our answers. Well, what next? Ooh, look at this one. I think you guys can talk me through this one. If we want to write an equation for a line that passes through those points, give me step 1. Find the slope. No, you find it. 7/5. Should we have any negatives in it? Okay. You got a favorite out of those points? You want to use -5, 0, or do you want to use 0, 7? Which one seems easier? Okay, choose this one. So y minus 0 equals 7/5 times the quantity x plus 5. Y equals 7/5 times x plus 5. Now instead, leave it in in point slope form. So you might be wondering, Cedar, why did you take this extra step? Is this simplified? We better all know what y minus 0 is. It's y. So it's simplified, that's why. There wasn't anything in there for y sub 1, it was 0. So we do have to simplify that by that last step. So if today, if this were it, and we were just supposed to write equations in point slope form, give me your 4, 3, 2, 1, 0. How will we feel about doing this? A couple people not feeling all the way confident yet, but getting there. So then we'll use this again. That's what we'll do. Let's not do that discuss this today. Okay. Parallel and perpendicular lines. Do you remember anything about the slopes of parallel lines? They are the same. The slopes of parallel lines have to be exactly the same. They have to be equal. The slopes are equal. That's what makes them parallel. You know, their rise over run is exactly the same. They're never going to hit each other because of that. Here's a tougher one. Do you remember what happens with the slopes of perpendicular lines? I heard a couple people, opposite and reciprocal. You're absolutely right. Negative reciprocals of each other. They have to be as different as they can possibly be, which is both the negative and the reciprocal. Okay, that's a fancy word. What does reciprocal mean? Yeah, flip it. You know, flip it. Top to bottom, bottom to top. So with parallel lines, the slopes are equal, but the y-intercepts are different. Hang on. Y-intercepts. Let's see. That would be here and here. Oh yeah, those are two different spots. Okay. That one over there says the slopes are negative reciprocals of each other, and the lines intersect at right angles. Ooh, remember your little geometry symbol for right angle? Draw me one in here. Yeah, you put a little box in one of the corners there. So 90 degrees. So to make that happen, it has to be as different as it can possibly be from the slope that you already have, which is negative reciprocals of each other. So what do we do? Well, we read this very carefully and figure out what on earth they want us to do. It says, what's the equation of each line, and simplify your final answer to slope-intercept form. We need a line parallel to this one through this point. I can't do that. I don't know the slope. Do you know the slope? It is y equals mx plus b. The slope of this line is 5. All we have to do is look. It's right there. And the point we're supposed to use is negative 2, 1. Okay, that's a point for the slope. That sounds like a good time to use point slope formula. So what's our left side going to look like? Y minus 1 equals 5 x plus 2. Everybody okay with that? All right, good. And now it did say put your final answer in slope-intercept form. So tell me what we should do then. Add the 1? No. Yeah, let's distribute. Then add the 1, yeah. We don't want to make the thing complicated. It doesn't have to be. There it is. Absolutely, that's going to be parallel. Look at that. The slopes are the same. 5. And they have different intercepts. This one would be at 0, negative 4, and this one would be at 0, 11. They're quite a ways away from each other. Well, that worked. Perpendicular is a little harder. Little, not much. Little. The line perpendicular to y equals negative 4x plus 2/3 through the point 8, 5. Here's why it takes a little bit more. Negative 4, how do you write that as a fraction? Okay, so here's what you need to do. You need to negate it, which means take its opposite. What would you get? 4, and flip it. 1, 4. That's the slope we have to use for perpendicular. Opposite, and then reciprocal. followed this in the notes. Well, there's our slope. Here's our point. Away we go. What's the left side look like? Equals. Now we have a fraction. It's not a horrible one. So what do we do next? Distribute 1/4. Okay, so that'll be 1/4 x minus 8/4 is 2. Add 5. Y equals 1/4 x plus 3. And we can check to see that this is perpendicular just by looking at the slopes. You know, our slope was -4, this one's 1/4. It's an opposite and reciprocal. At least we know we got the slope part right, you know? So, are there a couple more parallel and perpendiculars? Let's leave those till Monday, because I want to refresh your memory about this stuff on Monday. Let's just kind of stop there and do that. Okay. Now, pretty obviously, I want to see steps. If you don't show work on this, you get no credit because all the answers are in the back of the book. So, make sure I see your steps as you're finding your slope and everything else. And then on Monday, we'll start with the parallel and perpendicular again, and we'll start talking about something called standard form. You guys did great. You really did. You paid attention right away to that new formula and grabbed on with it. You did fantastic. So make sure you do the homework. Remember, put it in that long-term memory. Put it in there.
I'm missing